Hi girls, today we're going to be looking at the dihedral angle, and the dihedral angle is the angle between two surfaces. There are 4 steps in doing any dihedral angle question, and the dihedral angle usually comes up with the oblique plane, so there's no real avoiding it. Just explaining what it is, you have 2 different surfaces and they intersect together at the line of intersection. So where you have 2 different surfaces meeting, the line where they join is known as the line of intersection. Okay, and what we need to do is look along this so we can see an angle with 3 points on it. Okay, so when you join 3 points together, you can create 2 lines, and that gets the angle in between it. So going back to the steps, and it is really important that you take this stuff down, because when it comes to actually doing it, I will be explaining that. So the first thing you need to do is find the line of intersection, either in plan or elevation, and it's best to do this in plan usually. Okay, so in plan usually, find the line of intersection. From this point onwards, line of intersection, I'm going to abbreviate to LOI, line of intersection. You need to get the true length of this. In order to get the true length of anything, this means you need to take auxiliary. So this is auxiliary 1. Okay, we're going to be doing a few auxiliaries to do the dihedral angle. So by finding the true length of the line, you're taking an auxiliary. You're then going to look along the line of intersection to see it as a point. So you have learned through this topic already, when you have a line and you look along a line, you see the line as a point. You're then going to bring out 2 other points into that auxiliary. Okay, so this is the second auxiliary. And by doing that, you're going to bring out 2 extra points, 1 from each surface. You're then going to measure the angle, and that is the dihedral angle. So you're first of all going to find the line of intersection and get the true length of it. You're going to pick 2 points on each surface, and then you're going to look along it. That's taking the second auxiliary, and you're going to see the angle. So the 3 individual points, when you join them together, the angle in the middle is the dihedral angle of the 2 surfaces. So just recap, the dihedral angle is the angle between 2 surfaces. That's what we're trying to find. We are going to do a question that incorporates all of this, one of the easiest ones that's on the course at the minute, but it includes a number of different things that you're going to see new today. So you're going to do the 2010 B3 question. So this is 2010 B3. In the question, you have to set up points. So this is kind of like your X, Y, and Z axis on the Cartesian plane. But we're going to use it using the X and Y axis only. So from a starting position, you're going to measure in a particular distance. To get the point in elevation, you're going to measure up a particular distance. And then to find it in plan, you're going to measure down a particular distance. So when you see coordinates like that, and there's 3 different ones, it is in, up, down. We're asked to draw the plan elevation of the intersecting planes. We're then asked to get the dihedral angle between them. We're then asked to get the true shape, and we're then asked to determine the traces that contain that plane. So this is getting your VTH. So that's a standard question. It won't always come up with coordinates, but sometimes it does. Okay, and this is a question where it does happen, and it's just nice to get used to it. So when it comes to doing any question ever, doing any plan elevation, the first thing you draw is an XY line. Keep it in the middle of your page. Now, what the most important thing to do is pick a point to start. This is your point 0. Because when it comes to doing coordinates, you need to measure in 60, you'll need to measure in 90, you'll need to measure in 120 and 30. So picking a point to start is important. Now, it doesn't have to be directly to the left, but if you keep it consistent, it makes it easier to find everything else. Okay, so I'm going to start by finding A, B, and C and D positions. So 60, 90, 120. So from 0, I'm going to measure in 60. That will find me A, 90, B, 120, C, and then finally 30 for D. Okay, so A, B, C, and D. So that was the in measurement. With those points, you're going to do a vertical line at each one, because we're going to do the up and down measurement next. Now, of course, if you want to, you keep this more central in the page if you wanted to, but it doesn't really matter. If we run out of space, we can always stick on a page. So I've done this 60, 90, 120, 30. That was the in from the left. I'm now going to have to measure up 20, 60, 20, 70 and down 70, 40, 70, 50, 15, sorry. So I'm going to measure 20 at the 60 point at A, 60 at B, 20 at C, and 70 at D. So A, first of all, was 20. A and C is 20. So if I measure it once, the 20, and then I measure the 60 and the 70 at the same time, and I just bring these points across the page, it's a little bit easier. Now, A was 20. B was 60. C is 20. And D is 70. Okay, so I found all of the points in elevation. It tells me the two planes are ABC and ABD. That means I need to join A, B, and C together. So A to B, B to C, C back to A. So that's A, C, and B. And ABD is the other plane. Okay, so that's coordinates getting the elevation. That's the up measurement. The down measurement is 70, 40, 70, 15. So 70 is the biggest measurement we have. That's why I'm 70, 40, 70, and then 15. Just going to bring all of those across. Okay, 70 for A, 70 for C, 40 for B, and then 15 for D. Join them together. A, B, and C are all joined together, and A, B, and D are all joined together. Label all of the points really clearly. Now, so part A of the question was drawing out the two planes as you had been given. That's part A of the question done. Part B of the question is to determine the dihedral angle between both planes. Go back to your list. You need to find the line of intersection and then get the true length of it. The line of intersection are where the two planes meet. It has to be a common line between both planes. So these are the two planes. The line that joins them is here. I always said it's easiest to work from plan, and you'll see why in a couple of minutes' time. But we're going to take an auxiliary. An auxiliary is something that you'll use a lot in drawing. Pretty much in every single question that you'll ever do has auxiliaries in it. The important things from auxiliaries you would have learned in third year, but not in huge detail. So an auxiliary is looking at a line or a surface at a particular angle, and it allows you to get true lengths, true widths, true heights, so on. So this line here, I want to get a true length of it. So I need to take an auxiliary. The XY line needs to be parallel, and all the points need to be brought out perpendicular. So I'm just going to slide my set square away from the surfaces, and I'm just going to draw an XY line. So it's not intersecting anything. This is my first XY line. This is a new one. I'm going to call it X1, Y1. Okay. Now that I have that, I'm going to bring out A and B perpendicular to it. Some people find perpendicular difficult. I flip set squares. Some people slide them each to their own. It's just as easy. Okay, so bringing out A and B. In order to get the true heights, in an auxiliary, you always work from your last XY line back. This is my new one. This is my last one. And because I'm working from a plan, my last XY line back is our heights. So I'm going to take the height of A and strike it off from A. Then I'm going to take the height of B and strike it off from the ground back as well a second time. Now, so take the height of A. We know it's 20, like you could measure just the 20 and the whatever it was, the 60 again if you wish. It doesn't matter, you can just use your compass. So A is 20. B, the height of it, just take it from your drawing. It's 60, but you can just measure the height with your compass and strike it off. When you join these two lines together, what you've got is the true length of the line of intersection, and I'm going to label it like that because you get marks for this in the exam. True length of the LOI. So this is my line of intersection. Okay, I know it's a line of intersection because it's the thing that's joining the two surfaces together. I'm after looking perpendicular to it, so every point is after coming out perpendicular. The first thing I drew is an XY line which is parallel. And I measured the height of A from the elevation, the height of B from the elevation, and I'm after getting the true length of that line. Okay, now that you have that, we'll go back to the notes. It says, so we've done step 1, we've got the true length of the line that was taking our first auxiliary. Look along the true length line of intersection to see it as a point. This is a second auxiliary. Looking along it says exactly what it says in the tin. You're going to draw your line out along that line. And just as I see that, actually, wasn't very accurately drawn, that I'm just going to redraw it again, just ever so slightly get it a little bit better. Yeah. So look along it. That means draw it out. You're taking a second auxiliary, which means you need to do another ground line. So just perpendicular to this, you're going to draw in your next XY line. This is an X2, Y2. And like I just told you, when you do an auxiliary, you work from your last XY line back. This is X2, Y2. So my last one was X1, Y1. And I have to measure the distances back. You can see A and B are the same distance apart. So just take that distance on your compass. Everyone's will be slightly different because I didn't measure that distance, and you don't have to. As long as it's consistent in your drawing, that's what's most important. So A and B are the same distance apart because it's a parallel line. So from my new X1, X2, Y2, I'm just going to strike that point off. And now that was A, that was B. And now this point here is A and B together. So I've looked along the line and I've seen it as a point. I now need two other points so I can measure an angle. But I'll just go back to my notes so you can see where I'm coming from. So I've got the line of intersection, got the true length of it. I've looked along the line of intersection to see it as a point. That was the second auxiliary. I'm now going to bring out 2 points into this auxiliary, making sure you take one from each surface. So at this point, I've used A and B, so they're done. I need to take a point from this surface, and I need to take a point from this surface. There's only one left from each. I need to bring out C and D into this auxiliary, but you need to bring them out through each view. So this is working from the XY line, this view. So I need to bring this into my first auxiliary and then transfer it into my second auxiliary. I can't just move it directly into the second auxiliary. I need to move through the views. Okay, so when you do an elevation and a plan, they are directly linked to each other. Likewise, this plan, this is now an elevation. These two views are directly linked to each other. And these two views are directly linked to each other. So you can't just go from here to here. You have to work through the views. So I'm going to bring out C and D into this, which means I need to bring them parallel to my lines A and B already brought out. Okay, so bringing out D. For me, the C seems to be on the same line as B, and that's fine. But I just need to measure the heights. So D was up 70. So take that and strike it off. Now that line was not long enough. Okay, so there's D. And C was the same height as A. So I'm just going to transfer it across. So it was 20 high. So I'm just transferring the 20. So like literally this height here that I'm just after transferring is the same up in elevation. Okay, so it's the exact same. Okay, so I've got my 2 points, one from this surface and one from this surface, C and D. C and D now need to be brought back into the next view. Again, it has to be parallel to the way you brought it out. So I came parallel to the line of intersection. So bring out C parallel to the line of intersection and bring out D parallel to the line of intersection. We're going to do quite a bit of this because the dihedral angle comes up at least 3 times in every single exam paper. It comes up in part A, comes up in part B, and comes up in part C. So you really need to have a good handle on it. Now we're on this auxiliary. And to take measurements to get points out here, you have to measure from your last XY line back. This is X2, Y2. So my last one is X1, Y1. I have to measure back that distance. Back to C, strike it off. Back to D, strike it off. And as I was saying to you, depending on where you did your X1, Y1, like this distance might be different. Like you might have done it a little bit further back and that's fine. Okay, take the distance to C, strike it off. Take the distance to D and strike it off. Again, you can notice I'm taking it from the last XY line back and striking it from, so D was here, I'm bringing it out from my XY line to D. And that was C. The center of the surface, okay, is the line of intersection. So that's A and B. I'm going to have C on one side, I'm going to have D on the other side, and the angle is directly in the middle. So A and B has to be in the middle of the angle. So you're going to join C and you're going to join D to it. And inside here is the angle between the two surfaces. When you show dihedral angle, you have to show like the unit of measurement that it is dihedral angle. So like if you're doing a distance, you'd put like millimeters, centimeters, kilometers beside it to show what you're talking about. Likewise, when you're talking about an angle, you'd put degrees. But dihedral angle, when you're showing it on a drawing, you do 2 little triangular pieces pointing in towards the angle. And you put a dot in the center and you measure the angle. So it's 2 little triangular pieces and a little dot in the center. And then you grab your protractor and you measure the angle. And I think it's meant to be around 170, but I'll just double check it. Maybe it's 160. Now I'm getting around 163. But as I was saying to you before, when you were doing angles for the oblique plane, it was kind of plus or minus 5 degrees either side. So some people might get 158 or some people might get 170. That's fine. And you'll get the full marks for it as long as you've plotted all the points correctly in that. Okay, so I got 163 degrees on that. That's the dihedral angle done. That was part B of the question. Part C of the question is get the true shape of the triangle ABC. Well, in order to do this, and you do this in maths and have done it in maths, and it's one of the constructions for maths, is when you were getting the true shape of a triangle, you need the true length of all 3 lines. Now, I have a true length of this line. I have found it in plan here. That's the true length of the line AB. And as you can see, this is symmetrical. So this is symmetrical. So BC has to be the exact same length. And finally, this is a horizontal line in elevation. It's also a horizontal line in plan. So it's not angled in any direction. So it means it has to be a true length as is. So this is a true length. Now that's not the actual true length, but we have the true lengths of them. I'm just going to rub that out. Okay, so it's an isosceles triangle. So these 2 sides are the same length. In the base, we have the true length. So we have the true length of AB and BC. There it is. And we have the true length of AC. So we have the 3 true lengths. So anywhere on your page, you can do this, like you would have done in maths. So this is part C of the question. It's the true shape. And all you're doing is you're grabbing your compass and you're starting off with a horizontal line. We can even use this horizontal line if you like. And I'm going to use AC as the base of the triangle. So the first thing is you can pick a place to start. I'm going to call that point A. So I'm going to take A to C on my compass. So this is a true length. So take it on your compass and strike it off. So there is C. Now I need to find the position of B. So A to B and A to C, or sorry, C to B is this distance. So take it on your compass. And when you go over to the true length, A to B, strike an arc. C to B, strike an arc because it's the same distance as isosceles. And you've got the center point now, or the apex. You can just draw that triangle in. Okay, so you do this in maths. It's one of the constructions. You would have had to do it in junior cert, let alone leaving cert. And we found point B. So that's the true shape of it. Done. The last part of this question is to determine the traces of the plane that contains the triangle ABC. Now, there is a bit of a hint in this question. This surface isn't touching the ground. And I'm just going to refer you back to a sheet I gave you a couple of days ago. Okay, the sheet I'm referring to is oblique plane 6. Do you remember when we had the plane, but we didn't have the traces? We had to force points to touch the ground. And we replicated that down in plan and we got the VTH from that. That is what we're going to do now. So this plane, I can clearly see, is not touching the ground. So I'm going to force points to touch the ground, and when I have them on the ground, then you will see where the vertical and horizontal trace is. Now, this is not an oblique plane. I can know that by looking at it. But if you did an end view, you'd see it's not an oblique plane. But you're still asked to get the VTH. So I'm going to go through it quickly. So the plane isn't on the ground. So to find the traces of the plane, remember you can continue points on. AC won't work if I continue it on in both directions. It's never going to touch the ground. Whereas BC, if I continue it on, it does touch the ground. AB, if I continue it on, it also touches the ground. Sorry, I'm just going to draw that line a little bit better. Yeah, okay. So I've got those 2 points touching on the ground. I continued AB on, so I need to continue AB on in plan. I did the same at BC and I continued it on. And all you need to do now is bring down the points that touch the ground down flat or down perpendicular, and you will see where the 2 points are, and you'll join the 2 points together in order to get the HT. So bringing down BC till it touches, that has to be 1 point. Bringing down AB, see where it touches. You can see they're directly in line with each other, so draw that line in. So it's a horizontal line, that is my HT. Just label it HT. We now need to find VT, and in order to do it, all you're doing again is the same thing in reverse. So I'm going to continue on BC till it touches the ground in the opposite direction. I'll do it in a different colour so it's a little bit more obvious. Continue on BC, continue on AB, and see where they are in elevation then by bringing the points up. Again, you can't actually see that. So when I brought the point up, it touched on the blue line. When I brought the point up, it touched on the blue line. If I'm accurate, that should be a horizontal line. It's a little bit off. I don't know why that is. Just ever so slightly off, but it should be horizontal. I'm just going to do the best fitting horizontal line through it. That's my vertical trace. Another way you could have found this simply inclined plane is by doing an end view. So basically what's happening here is, just to show you a little bit better. This is the surface. It is it's triangular in shape. Sorry, I'll do the last page of it. That's the triangle, ABC. It's tilted at an angle, but if you look in at the side of it, you'll see that it's just sloped. And I'm just going to draw what that would look like. If you did an end view, you'd also see that it's a simply inclined plane, and you'd be able to get the VTH just as easily. So By doing an end view, you'd normally bring points out to the edge, you'd bring them up at 45 degrees. You bring A and B onto the correct lines. So B is here, A and C is here. And then I'm just going to find that. That would be where the HT would be on the ground, and that's where the trace is on up high. So you can see a little bit off. Oh yeah, that's right. I see it now. I have my plane. That was the plane ABC. But if I continued it on in both directions, where this line is, I should have a point on it. Sorry, this line here, where that is, I should have a point on my HT, and I do. There it is. And you just bring that line across and you get your VT. Same with this one. I did it already. I've brought it at 45 degrees. The point where it touches on the HT through that corner. Okay. So it's a second way of getting your simply inclined plane. You can just see that the plane AC is resting at an angle, and that's the true angle that it's resting at. And yeah, your VT and HT are just horizontal lines. That's it. That's part D of the question done. So at this stage, we've actually done quite a bit today, in the sense that we've looked at coordinates in, up, down. We've looked at getting dihedral angle. So there's 4 steps in doing it. We've looked at getting the true shape of basic shapes. And we've looked at getting the traces of a plane. Now, it didn't say it was an oblique plane. It just said get the traces of the plane. When the plane is off the ground, you're using that slide 6 or oblique plane 6 question that I was on about. Okay, forcing points to touch the ground. You'll get 2 points. You join the 2 points together wherever it touches the XY line. If it's oblique, you then come parallel to any other point and you get the VT. But for this particular question, when you continue the 2 points on, you just got a horizontal line. If you do it the opposite direction, you'll get the VT, and that will work for any single question. Okay, so that was 2010, and I think it was B3, but I'm just going to double check that. 2010 B3. Yeah, 2010 B3, parts A, B, C, and D done.